Welcome back. Our 10 recruits have mastered 36 of their 100 basic multiplication facts and are ready to tackle some more. This time they'll be meeting with 2, and he calls this lesson, Make That a Double. I wonder why he chose that name. Sounds more like an order at McDonald's. Let's join them in 2's cabin so we can learn the strategy behind the name.
Good morning, recruits.
Good morning.
How many of you know your doubles?
We all do, right?
Yep. Sure do.
Excellent. Well, we're all done here. What's the matter? You look confused. If you know your doubles, then you know my set of facts.
I don't get it. What do our doubles have to do with our multiplication facts?
Let me see. How can I help you make the connection between your doubles and your 2's in multiplication? Oh, I know. Let's go back to the example 1 used in his lesson. Remember, with plates and cookies. This time, I want you to imagine there are 2 plates, and each plate has 6 cookies on it. Can we find the total number of cookies using multiplication?
You can, because you have the same number of cookies on each plate.
Exactly. So, who would be the maker in this op?
You would. Since there are 2 plates with 6 cookies each, you would make 6 at his number 2 times.
And 6 would be the doer, since he has to do the work of adding his amount.
Perfect. Go ahead and grab your whiteboards, recruits, and write the secret code for this multiplication operation. Now, show me your code. Nice job, recruits. Now, if someone was to read your code and set about to carry out the operation, how would they go about it?
They would add 6 2 times.
Are you saying that to find the product of 2 times 6, you have to add 6 and 6?
Yes, sir.
Then what's the product of 2 times 6?
12.
So you add 6 2 times to find the product of 2 times 6. Hold on to that thought. Okay, so let's add a few more cookies to this scenario. Now how many cookies are on each plate?
8.
Can we find the total number of cookies on these 2 plates by using a multiplication operation?
Yes, you can, because both plates have the same number of cookies.
Exactly. Question: has the maker changed for this operation?
No, you're still the maker, since the number of plates hasn't changed.
What about the doer?
The doer's now 8, since 8 will be doing the work of adding his amount 2 times.
Great. Go ahead and write the code for this operation. Excellent. Now that we have the code, we can complete the operation. How would we do that?
Since 2 is the maker and 8 is the doer, we would add 8 2 times.
Which means that the product of 2 times 8 is 16. Now, I want you to do what 007 always stressed that you should do, which is to strategize, to devise a way to use this information to your advantage. Let's make him proud by doing exactly that. Who wants to try?
I would, sir. I noticed something I think we can use. I noticed that anytime you are the maker, the doer will be adding his amount 2 times, meaning he'll be doubling his amount.
which also means that 2 times any number is the same as that number doubled.
Nice work, you guys. And we can easily turn that into a rule. What would the rule say?
2 times any number is the same as that number doubled.
Perfect. Now, let me ask you something. Will this rule still hold true if I'm not the maker, but the doer?
I'm not sure.
Maybe.
I think so.
Let's try it and see.
Okay then. Let's say we have 6 plates of cookies with 2 cookies on each plate. Who is the maker in this operation?
6!
And I'm the doer, right?
Right.
So how would we find the product for this operation?
6 will make you add your number 6 times. 2 plus 2 is 4, and 4 plus 2 is 6, and 6 plus 2 is 8, and 8 plus 2 is 10, and 10 plus 2 is 12. So, 2 times 6 and 6 times 2 both equal 12.
Indeed they do. Not only in this example, but any time you switch the order of the maker and the doer in a multiplication operation, the resulting product will still be the same. Since this is always true, it can be made into a rule. We numbers call this rule the multiplication rule of order. Any ideas as to why we might call it that?
That's easy. Rules are something you're supposed to follow. An order is the way things are arranged, like first, second, third, and so on.
And I think it's called the multiplication rule of order because you use it on a multiplication op.
And the order part of the name is there because it refers to changing the order of the maker and the doer.
Does that make sense to the rest of you?
Makes sense to me. Seems easy enough.
Can I try it out?
Sure.
According to the multiplication rule of order, if 2 times 8 is 16, then 8 times 2 will also be 16.
You are correct, and that is precisely how you can put this rule to work for you, especially with my set of facts. All of you know your doubles, so you already know 2 times 1 all the way through 2 times 9. And because of our new rule, you also know the facts that result when you switch the order of the maker and the doer. So you also know 1 times 2 through 9 times 2. Let's try a few. I'll write a fact on the chalkboard here, and as soon as I'm done, I want all of you to call out the product. Don't worry if I'm the maker or the doer on the operation. The product will still be what you get when you double the other factor, whoever is working as my partner on the op. Ready? Here we go.
10! 14! 18! 8! 6!
I knew you would rock at my facts. By the way, you might as well know that mathematicians came up with a different name for this rule. They like to refer to it as the commutative property of multiplication.
The what?
Can you repeat that?
That's a weird name.
Why do they call it that?
Well, I suppose they chose that name because the word commutative comes from the word commute, which means to switch places. And a property is something that is common to all members of a group, which in this case would be multiplication facts. I suppose they call it that because one thing that is common to all multiplication facts is that the maker and the doer can switch places without changing the resulting product. Now does it make sense?
A little.
Somewhat.
Yeah.
I like your name better.
I'm glad you like it. Now remember when Agent 007 taught you the rules for the multiplication operation?
You mean the rules about odd and even? Like even times even equals even?
And even times odd equals even?
And odd times odd equals odd?
Yep, the very ones. So what kind of number am I? Odd or even?
You're even!
Ready to use your powers of deduction? What does that tell you about the products of my set of facts?
They will all be even.
So now that you understand the doubling strategy, you're ready to get some intensive practice with these facts, right?
Yes, sir.
Don't look so glum. I know doing drills with Sergeant 3 isn't your favorite activity here at the camp, but you need to understand that these drills are forging pathways in your brain that will allow you to find the identity of Agent X with lightning speed.
Ready to forge some pathways of your own? If you click on the link to the Numbers website, which is posted below, and navigate to the section called Drills and Other Resources, you will find a folder named Drills. Print out as many copies as you need of the drill called Twos in Multiplication. Once you can fly through these facts with great speed and accuracy, print out the drill zeros, ones, and twos and see how fast you can answer these. Keep at it till you're going so fast that smoke is rising off your pencil. Just kidding. Meet us back here when you're all done, when the recruits set out to master 5 set of facts. Have fun with Sergeant 3. Two's crew here signing off.